Hello, Mr. McFarlane here, and today we're going to be talking about the concept of, ready for this? Magic. Limiting reactants. Alright? Now, limiting reactants basically means something that limits the reaction. So, a reactant is the thing that you start with. A product is the thing that you end up with. So you start with reactants, you get the products. So a limiting reactant is something that's limiting the reaction. Now here's an example. Let's say that a cake requires 3 eggs and a box of cake mix to make it. Okay? So if I have 3 eggs and a box of cake mix, I can make 1 cake. Good. Now, limiting reactant would be something like if I only have 2 eggs and 1 box of cake mix. Now I can only make enough cake that the eggs would support. Let me back up. Which one of these two is limiting the other one? It's the eggs. Here's why. How many cakes can I make with 2 eggs and a box of cake mix? I can make 2/3 of a cake, right? Because I only have 2/3 of the eggs that I need. I have enough of this, the cake mix, but I don't have enough eggs. So basically, a limiting reactant is the thing that gets used up first. The eggs in this case get used up, and this doesn't. So that's limiting. Alright? So, let's do a chemistry example. Alright? So here is a reaction. It's not balanced. But it's lead 3 chloride plus iron 2 hydroxide making lead 3 hydroxide and iron 2 chloride. So that's a reaction. I just made it up. I don't even know if it's possible or not, but for the purpose of this lesson, I made it up and we're going to do it. So here we have our starting things in green. Those are your reactants because those are the things that you start with. Your products are made in red. So let's say that we started with 30 grams of this, lead 3 chloride, and 30 grams of this, iron 2 hydroxide. Okay? What will I get in return is the question. What am I going to end up with? So here's how you do it, step by step. Step 1. Pick one of these. Pick one. Okay? We'll just go right in order. We'll start with the lead 3 chloride. Alright? Pick one and convert it to moles. So, number 1, convert to moles. Okay. Now, the way that I like to convert to moles is to use the bracket method. But I'm not going to do that here because it's not what a lot of people are familiar with. A lot of people are familiar with just plugging and chugging in numbers. So I want to do another way of doing this, and it's the triangle method. Okay? This triangle, which I usually just have this memorized, or I usually just pull it up somewhere, is very useful in figuring out moles and atomic number, or atomic mass, sorry. So basically, how this triangle works is, if I want to convert to moles, I start with what I know. So we're focusing right now on lead 3 chloride. Start with that, start with 30 grams of that, and that would go in your grams section of the triangle. So the 30 would go in the grams section. So actually, I'll just write that in there in green. And hopefully you can see that okay. So 30. That goes into grams. So I said step 1 is to convert to moles, right? So I have to get to this part right here. So how do I do that? I have to divide, if it's on top, I have to divide it by the atomic mass. The atomic mass of the thing you start out with. So I have 30 grams of lead 3 chloride, so I have to divide by the atomic mass of lead 3 chloride. Okay? So how do you figure out the atomic mass of that? Well, I look on the periodic table. So hopefully you can see this okay. Pb is lead. You can find it on here. I'm looking at it backwards, so and plus the numbers are really small. But we look at the periodic table. It's down there in ways the mass of lead is roughly 207. It's 207.2, but you can round the masses if you would like. So 207 is the mass of lead. Now you have 3 chlorines, so you have to add the mass of each of those separately. So you have one chlorine will be a mass of 35, another one will be a mass of 35, and a third one will be a mass of 35. Okay, so then in my handy dandy calculator here, I type in, clear it for you. So I type in 207 plus 35 plus 35 plus 35. Just like that. Enter. I get a mass of 312. All right. So my mass of lead 3 chloride is 312. All right, good. Now my grams is 30, my mass is 312, so in order to find moles I have to take grams divided by atomic mass. So my handy dandy calculator, I sound like Steve from Blue's Clues. Handy dandy notebook. Okay, I typed in 30 divided by 312 and I got 0.096 for moles. So 0.096. Okay, so I'm actually going to write that. I'm going to write that in big bold red. Alright? So 0.096. So that's step 1. Convert to moles. So I'm actually going to erase this triangle to get more space for you. And for me. That's step 1. So I wrote that up there. So the grams is the mass, or mass is in blue, moles is in red. Right? So that's moles of lead 3 chloride. Right. So step number 2. Okay, once you have moles, you have to I guess a good way to say this is multiply or divide by the ratio. Now the ratio is the ratio, it's basically a comparison of your starting thing and your ending thing. So we can pick at anything. We pick the starting thing, we can pick one of these ending things to compare it. So I'm going to say, I want to know how much lead hydroxide. So I want to know how many grams of this I make. Right? So how many grams of that? So when I say multiply or divide by the ratio, that's confusing for a lot of people. They're like, what ratio? Well, the ratio refers to the balanced formula. The balanced formula states that you have to start with the same number of atoms as you end with. Right now, this formula is not balanced. So I'm going to erase this to get more room. I'll write it back up in a little second. Okay. So, we have to balance the formula for step 2. Okay. So, how to balance formulas, we went over this a couple times. Basically, you go bounce back and forth and count the number of atoms on each side and you put numbers on to balance it out. So, start with lead. There's 1 on this side, 1 on this side, so it's good. Go to chlorine. 3 on this side, 2 on this side. So, I'll even do this in black. I can put a 3 here and a 2 here, and that helps because now I have 6 chlorines on this side and 6 chlorines on this side. Okay, now that changes my PB. I have 2 PBs on this side, if you can see that okay. I put a 2 in front of that, just like that. I got to change the PB on this side. So 2 PB, 2 PB. My OH is now 3 of these in the brackets and 2 here. So, sorry, 3 times 2 is 6. So that means I need to have a 3 here. Okay, so now let's double check. PB on this side, 2. PB on this side, 2. Cl on this side, 3 times 2 is 6. 3 times 2 is 6. Fe, 3. Fe, 3. OH, 2 times 3 is 6. 3 times 2 is 6. So we're all good. So the ratio is basically the numbers in front. 2, 3, 2, 3. That's the ratio. All right? Now I made it this ratio on purpose. Instead of doing a 1 to 1 to 1 or a 1 to 2, I want to make it a little bit trickier so you can get the hang of how to do this part. So we started with this, the 0.096 of this compound. All right? And you know what, just to make it tricky, this is why I do it. We want to know this. Originally I said this, but I want to make it a little bit more difficult. We want to know grams of this. So I'll keep that all in blue. So 30 grams of this, 30 grams of this. I want to know grams of this. All right. So step 1 was to convert to moles. Done. All right. Step 2, basically you have to write the balanced formula and then multiply or divide by the ratio. All right. Here's what that means. I have 2 of these. Okay. I have 3 of these. What do I have to do to get from 2 to 3? What mathematical formula can I do, either multiply or divide to get from 2 to 3? Well, I could divide by 2 and then multiply by 3, or I could multiply by 3, so you'd have 6 on this hand, divide by 2 to get to 3. Basically, however you can do it in your mind, you can do it that way. What I like to do, you never get it wrong this way, is start with that, do it in red because it's moles, 0.096, multiply by what you start with, times 2, divide by what you're looking for. Alright? So, sorry, reverse that. Multiply by what you're looking for, divide by what you start with. Now this makes sense. To get from 2 to 3, you have to multiply by 1.5, right? If you take 2, multiply by 1.5, you get 3, right? 3 divided by 2 is 1.5, so this times 1.5 gives you your answer. So, start with 2 moles of this, end with 3 moles of this. That's a 3 to 2 ratio. This times 1.5, I'll do that in the calculator. 0.096 times 1.5 gives you 0.144 moles of the new substance. Okay, so we got 0.144 moles of the new substance. So this stuff is 0.144 moles. So it's more. So with 0.096 moles of this, 0.144 moles of this. Step 3 then is now you got some new information. You started with this stuff, now you have this stuff. Alright? Started with this stuff, now you have this stuff. So 0.144 moles of this, you put that right back into the equation to find out grams. So if you remember the equation, so step 3, I should actually write out step 3 first. Plug the moles back into this to get grams. Alright? So, here's what I mean by this. You get grams on top, you get moles on the bottom, and you have atomic mass.